Welcome to Source HeroCon 2023. My name is Aaron Martin. Myself and Savannah Lazzara will be giving a presentation on breaking into the cloud. So some quick introductions. Aaron Martin, technical manager with Optiv. I have about 10 years experience in information security, and additionally 7 years with Optiv, working primarily in adversary simulation. And I can be reached at my keybase, Aaron_Martin.
Awesome. My name is Savannah Lazzara. I'm one of the technical managers on the Attack and Pen team. I'm also one of the co-leads for Red Team Village, and I'm also one of the adversary sim operators as well. And I would say the best way to reach out to me after this presentation, if you have any questions, is through Twitter. So kind of kicking off the agenda, we're going to be going into a few different topics today. So our introduction, cloud environments, discovery, enumeration, and then common initial access methods, and then diving into post-exploitation after. So before we even get started with going through anything, we want to make sure that anyone who is watching this presentation knows that anything we discuss, you do need proper authorization for whoever you're doing testing for. So we are not responsible for anyone you do testing for if you don't have the proper authorization in place. So that's just kind of a FYI. So that's why we have this little gift right here. So diving into different types of cloud environments, in this presentation, we're going to kind of go through AWS and Azure. So we broke down the types, as you can see on this slide right here. So you have virtual servers, platform as a service, serverless computing, Docker management. I'm not going to run through each row, but this just kind of gives you an idea of the different types of services associated with each provider. So they just have different names. So EC2 instances would be for AWS, and then Azure would be virtual machines, and then the S3 buckets for storage in AWS versus the blobs in Azure.
So now we're going to be going into a high-level methodology of what basically encompasses a cloud penetration test, and most of these we will be going into more detail. So just a quick overview of the methodology here. So as you can see, it pretty much mirrors a standard penetration test with a few key differences, starting with discovery, going into enumeration, and vulnerability identification and cloud misconfiguration kind of go together as there are some documented CVEs for strict vulnerabilities in a cloud environment. A lot of what we're going to be talking about and what you'll find on these kind of tests is misconfigurations within the cloud resources themselves, which can lead to initial access to either laterally move through the means of misconfiguration or through social engineering, which we will also be talking about. And then finally, using those credentials or access to conduct post-exploitation activities. So moving into discovery, we're going to start with open source intelligence. Like I said, on a traditional pen test, you'll likely do open source intelligence against a target environment. In this case, we're strictly going to be speaking about open source intelligence as it pertains to cloud resources. So it follows the same attack path. You're going to be looking for subdomains of organizations that may be tied to cloud resources. You're going to be looking at public code repositories, GitLab, things of that nature. You'll be looking at IP ranges specifically for cloud resources that a company may be running, such as virtual machines. And we touched on that subdomain enumeration. Just a quick note on subdomain enumeration. There are some vulnerabilities such as subdomain takeovers. There may be cases where you might find an organization has stale DNS records. I've seen cases where S3 buckets were tied to a CNAME record that was hosting a page. This could be a big vulnerability if a company is unaware of these stale DNS records that can be potentially taken over to serve malicious content under the guise of the actual organization domain. Moving into AAD internals. So basically this is in Azure, query for cloud resources. So AAD internals is a collection of PowerShell modules that is very robust and powerful, can be used to enumerate a lot of objects once access is gained to Azure. But from an open source research, it can be used to list an organization's tenant information. So the benefits of this is you'll be able to see if an organization is either managed or hybrid managed in Azure, and you also be able to see what other domains are managed under that tenant. So for potentially gaining access to other organizations that may be tied to the same tenant, these are likely associated with the parent company.
And kind of going into some of the common services that we do see in different environments, I would say number one, AWS is the S3 buckets, AWS apps as well, and then kind of going down the line, EC2 instances, Lambda functions, web apps on the AWS side. And it's kind of similar on the Azure side, the storage accounts, kind of finding that information through GitHub repositories. If someone has that information within there, you can kind of take those account keys and then leverage those for accessing some of the blobs that are in that organization. And then the databases, the virtual machines, and the web apps as well that are associated with Azure. So kind of going into the discovery tools, there's so many. There's just so many out there, but these are kind of the ones that I would kind of break down with in regards to discovery. So Cloud Enum can be used from a discovery perspective, enumeration as well, but it can be used with different cloud providers. So with AWS or Azure in this case, and then with Census, that's associated with the certificates. So kind of seeing if there's a valid certificate, or even if it's expired, then you can see what certificate is associated with whatever asset it is, and then kind of identify different cloud assets using that type of method. And then with GoBuster, you're kind of brute forcing the cloud asset names based off of keywords that you can kind of load up in a list. So there's various modes that are available in GoBuster for you to use. And then with Google Dorks, these are a few examples that we kind of have listed right here on this slide. But everyone, I feel like, who should be watching this would obviously know what Google Dorks is, but kind of leveraging that to then step up in the next level to find different cloud assets through other means besides some of the tools that we have listed. And like I said before, there's so many other tools. These are just kind of like the top 4 in relation to discovery that we wanted to include in this presentation. So diving in to enumeration. So kind of before we get started with enumeration with AWS, I kind of wanted to make sure we cover the different type of access types. So many people kind of have a misunderstanding with the different types of access, but I would say the biggest way to understand with AWS is that they have it with IAM. So that's the Identity and Access Management in AWS. So that's how they kind of break down who has access to what services and resources within AWS. So then breaking it down further from there, you kind of categorize it from authenticated, authorized, and then publicly available, which would mean authenticated is you have an AWS account, but you may not be able to access, say, another organization's resources. So you'd be kind of considered an anonymous user, versus an authorized user is someone that's within that organization and you have those permissions to be authorized to access the designated resource. And then lastly, the publicly available it's just open to the world. So think of it as S3 bucket. You can set the permissions on an S3 bucket to anyone can view. You don't have to have an AWS account necessarily. So that's kind of breaking down that access type. So diving into further enumeration associated with AWS. So you kind of want to look at it from the authorized perspective versus the authenticated. So with the authorized perspective, this is going to be if you have those permissions that you're kind of looking for in that organization, or from an authenticated perspective, you can see what you can access in that organization if you have some information like the account ID, and seeing what you can do from an anonymous standpoint and to that organization itself, or from an authorized standpoint, you can see what other users are in the organization itself, and seeing if maybe you can leverage an assume role. So if you can assume role, if say if there's an S3 bucket and the permissions are improperly misconfigured, then you can try to assume the role of that S3 bucket and then have the same permissions as that S3 bucket is configured to have. And that would be kind of abusing the assume role in place associated with that policy. And we're going to kind of go into further detail with that type of abuse in the next few slides. But that's kind of taking that IAM enumeration. That would be one example. There's various other examples that can kind of be used. So with PACU, which is a tool from, I think, Rhino Security Labs, you can leverage that to kind of dive into different AWS services enumeration. And we'll mention PACU in a few further slides down as well. And then with AWS applications, you can kind of start to look for the server-side request forgery. So that's something that's gaining a lot more popularity back again, just because all of these apps are vulnerable if they're misconfigured. So they have to have that misconfiguration in place. But if you are able to identify CSRF is applicable to this application that you're testing, then you can try to see if you can pull the metadata associated with that EC2 instance, and then get those credentials from that metadata that's on the EC2 itself. And lastly, so Cognito is something that I think everybody should be looking for on any AWS app. So that's Amazon's IDP. And essentially, if an organization is using Cognito as their IDP with some of their web apps, you can try to see if there's any misconfigurations in place, which would kind of lean towards them having the default configurations. So there's an attack scenario that we're going to go through later on in this presentation in regards to Cognito. But if they have it set up with default configurations, we can abuse that to add a user and kind of get credentials from there as well. So that's kind of, we're going to be going into further detail, but these are the kind of the top 3 things that I would initially look for. And in regards to the metadata list that we had, that we discussed on the previous slide, this would be kind of a breakdown of different URLs that you can test from an AWS perspective. So I'm not going to read out loud these URLs, but this is kind of more from a resource standpoint for anyone who's watching to have. So the assume role abuse that I was previously discussing, so this is a screenshot from Rhino Security Labs assume role kind of breakdown, but this shows how there's this star that's right there. And so that star is kind of saying that anyone can basically take, can assume that role. So it's having that misconfiguration. It's not, you're allowing any user to kind of assume that role associated with that policy. And that's, I mean, it's obviously not intended, but so that's why you should kind of always specify and be more granular with the permissions. But this is an example of a policy, if you were to look at it associated with the assume role, that any user can assume that role.
All right, awesome. So now we're going to be talking about some of the different flavors of Azure as it pertains to how you set up your internal network. So there's a few different options here. Azure Active Directory Domain Services. This is your traditional on-premise solution. So many of the things that your typical Active Directory would have, such as group policy, LDAP, Kerberos authentication, these are all functionable with Azure ADDS. The main difference being you don't have to maintain and patch local domain controllers. This is all completely done in the cloud. The second one is Azure Active Directory. This is a cloud-based directory service. Instead of your traditional LDAP used by on-prem domain controllers, all access to resources are done through HTTP requests. So for authentication and authorization, you have a few different options: SAML, WS Federation, OpenID, and your standard OAuth 2.0 are all examples that can be used for that user authorization. And for hybrid setups, Azure can connect and sync data from your local AD to Azure AD. So this enables you to extend your on-prem Active Directory into the cloud. With a feature called pass-through authentication, your Active Directory users can maintain the same password that can be used for both their local Active Directory and Azure Active Directory accounts. Cloud-specific roles and accesses would still be needed to set up and granted to users to give them permissions to different applications and resources. And later on in this presentation, we'll be going over how some of those misconfigurations can be abused. And one last thing, the main difference between local AD and Azure AD, Azure AD is a flat hierarchy, so it does not support multiple domains like your typical local Active Directory would, which can have various domain trusts across the network. So that is one of the downfalls. And then lastly, Azure role-based access control. So this is basically Azure's form of principal of least privilege. You can assign resources and roles to different users and applications, allowing them strict access to that role or application per se. We'll be going more into also how that can be abused. So moving into some different ways you can do enumeration. So we've all done a standard password guess against M365 services, but let's say you can gain access through some valid credentials. You have some different options there. There's a tool called MFA Sweep. I'm sure there's a multitude of others, but basically what this does is compare those credentials against other M365, including Azure APIs, to see if any of them may be enabled with single factor authentication, which can allow you to conduct further enumeration against a specific tenant in Azure, such as enabled app services, enabled storage accounts, as well as any SQL databases that may be running. Typically, these are going to pertain to the role of the user that you have credentials for. But like I had mentioned earlier, there are ways to abuse these to gain additional access and privilege escalate. And lastly, you can use Azure's CLI to authenticate and use various PowerShell modules to identify any additional permissions that you may have for the target organization. And one thing I did forget to mention, if server-side request forgery or command execution is applicable to any identified Azure applications, there's a specific attack scenario we'll be going over in a little bit that can give you the ability to obtain access tokens for whatever account is running under that specific application. Azure Access Tokens. Okay, so we'll start by talking about managed identities. So when you use managed identities, this kind of falls under that principle of least privilege. What you're trying to do is grant a specific resource, such as a web application, access to other resources, such as storage accounts or Azure Vaults. This is useful when you're granting a web app access to other private resources without storing connection strings and configuration files or source code, or without giving that web application too much access to do other things and have other permissions within Azure. So let's say you do find a command injection vulnerability, and let's say you can upload, say, a PHP web shell. There's some curl commands that you can use to upload under the PHP web shell, and it will execute within the context of that web application. In turn, you can gain access to access tokens that may have privileged access to other resources. Moving into enumeration tools, we're going to talk about a few here. There's definitely a multitude of others, but these are just some that we like to use on some of our cloud engagements. Token tactics, we'll be going over in a little more detail, but basically this is Azure JWT abuse toolset. It can be used in phishing campaigns, or if you already have access to Azure access tokens or refresh tokens, they can be used to uh, uh, trade out refresh tokens for other tokens associated with different APIs in a pretty seamless fashion using PowerShell. PackU is an AWS exploitation framework. It has over 35 modules, I believe. It's very robust. It can be used from a penetration perspective to find privilege escalation paths, but it can also be used from an auditing perspective if one was looking to audit the roles and permissions and identify any attack paths in their environment. One of the other cool things with PackU is you can use it for obtaining GUI access with access tokens. It will transfer that into a GUI that can be used to access AWS if you didn't want to use the CLI. Microburst, it's a PowerShell toolkit for Azure attacks. So AAD internals is the a very robust framework with a lot of different PowerShell capabilities for integrating with Azure and enumerating Azure. Microburst takes some of these and adds onto it, turning them more into an attack approach versus an enumeration. So it can identify um, Azure run books that you may have access to, service principal abuse, key vaults, uh, and the ability to create or access virtual machines, things of that nature. And lastly, Azure Hound. This is basically off the premise of Bloodhound. It will take in access tokens, and you can use it to enumerate basically an entire Azure tenant and all the specific roles and associated accesses that you have. Then you can obviously export this into JSON format, which will give you a neat little graph that can show you escalation paths to a specific user that you may want access to, or a specific role or principal within that company's tenant. Moving into initial access. So we're first going to talk about AWS and device code phishing. So um, I'm sure everyone's familiar with single sign-on. AWS integrates this to allow for seamless integration with third-party apps such as Okta or G Suite using SAML authentication. Um, this tool, AWS device code phishing, is a common configuration within AWS SSO that lets you register a device code. And with that device code, you can potentially assume the access of the user that you are, let's say, sending a phish to. So the reason you would want to do something like this is it allows you to bypass security authentication mechanisms such as MFA. If a user was to access that device code that you send them from an authenticated web browser, you would gain access to their access token and can use that to further enumerate roles within AWS itself. So continuing on with device code phishing, some certain information is required. This can be done during the open source enumeration of your target. You're basically looking for the company domain name prefixed before awsapps.com. So whatever your target organization is, will typically, if this is enabled, will have a URL that ends in awsapps.com. And lastly, the region will need to be configured as well for the primary region that you are trying to authenticate to. So this is just an example of the attack flow of a device code phish. So as you can see there, there's a couple different tools you can use. In the previous one, we mentioned the Python script that we've used before in the past. Basically, what it does is uses that configuration file that you input, and it generates a device code. I believe these are valid for 900 seconds. So that is a downfall of this if you are conducting a phishing campaign, is you do have a limited amount of time for that user that you send this URL to actually authenticate and authorize it. But as you can see there, it's pretty automated in the fashion that once a user allows authorization and registers that device code, it will automatically write that access token to disk or to whatever system you're using, and will begin enumerating roles that potentially that user can assume. Continuing on with AWS device code phishing, this is a pretty neat tool that can be used to bypass that 900-second interval. So your device code will no longer be only accessible for that amount of time. Basically, it uses an AWS gateway, API gateway, and different Lambda functions, as you can see there in the screenshot, to generate an API gateway that, when accessed, will start the flow of creating a device code URL that the user then has 900 seconds to allow to authorize their device. So the polling doesn't begin until that user actually clicks the Amazon API gateway. So this gives you some additional time when sending out phishes to gain access to that user's authorized keys. And as you can see there, the way you gain access to those keys is you can quick curl command with an API key that is provided to you, and you're just polling for those different Lambda functions that you see there that will give you access to a user's token if they did authorize a device. So just a neat way to get around the initial limited amount of time that you have when you generate these device codes, is to use a tool like this that gives you a much longer threshold. So the mitigations for these, basically, you can create email gateway alerts that blocking URLs that might contain device.sso region, Amazon AWS.com. If you typically know that that's not used in your environment, it could be indicative of a phishing attack. Additionally, in AWS itself, you can set up cloud alerting for SSO list applications and SSO OIDC create token when the source IPs differ for the same user. So when we create these API calls, it's obviously going to come from a different IP than when the user actually authorizes their device. So alerts can be generated for that. And additionally, you can audit and limit role access for accounts to only do business-related activities that they need. So if access keys are gained for a specific user, limiting their roles could potentially thwart any privilege escalation abilities that an attacker might have.
So kind of going into the Cognito thing I had mentioned earlier in the presentation, this is how Cognito is meant to be used. So a user will sign in, access that user pool, and then it's going to return whatever access they do have, and then get the credentials for that user, and then also interact with the identity pool, and then see what the user in that identity pool has access to those AWS services, and whatever service is trying to access, it's going to provide the tokens it needs to access whatever that user is trying to log into or access from the Cognito standpoint. But so we're going to be talking about how you can actually abuse it. And to me, I think this is one of the coolest, I guess, newest AWS kind of attacks. We recently, Aaron and I actually got to use it on an engagement, which we thought it was really cool to kind of abuse this. So we're going to kind of walk through how someone can essentially abuse that. So typically, whenever you are looking at an AWS app, if the client has Cognito built into it, you can kind of look at the requests that are going back and forth. Like, and if you were to open up the network requests whenever you're loading that application, if you see any Cognito, anything reaching out to Cognito, you kind of want to dive into that and see if you can see the JDK code. So a lot of the times, organizations will have the user pool ID in the user pool region. So those two items aren't necessarily bad to have. It's having that identity pool ID in there as well. That's when it kind of shakes things up and allows attackers to kind of abuse that. So you can still abuse this misconfiguration if it's just the user pool ID and user pool region. But having that identity pool ID would be very valuable, as you can tell in the next few slides when I go through it. But essentially, this is how it would look in that SDK file. So you would just want to kind of look for that type of information. Typically, you can do like kind of query, like the search for on that page, like US East or whatever, to try to find in your requests and the responses to see if you're getting any regions back in those SDK files that you're pulling. So if a Cognito, if the organization has Cognito and they have the sign up operation enabled for that user pool, we can leverage that to essentially create a user through the command line with AWS rather than going through the actual GUI itself. So you only need the user pool ID in the region, and you can start. So say if there's a bunch in a file, in the SDK file, you can essentially just try to hit all of those. And some of them may say that sign up operation is disabled. So that typically means only an administrator can create an account. But if it is enabled, like in this case, so CloudGo actually has a lab where you can kind of simulate this type of attack and kind of see how you can kind of run through this type of attack in relation to Cognito. But essentially, you can add a user to that user pool. And then if you kind of get that successful response, then you'll get an email with a verification code, as you can see right here. And then the next step, we'll show you how to kind of verify that user. So once you get that confirmation code, you'll enter in this command, and that's going to verify that user. So now that you have a user in that user pool associated with Cognito, then you can go back to the GUI and then log in. And essentially, if that user doesn't have like proper permissions associated with the application might respond kind of weird, like it might be like error, like, or something like this, like user's not a part of any groups. That's essentially because they probably aren't, because you just created it and we haven't gotten to that level. But you want to look at, if you open up like the storage tab on Firefox, Chrome, whatever you're using, those tokens that Cognito is essentially generating. So it's going to generate a few different types of tokens. So you'll see that, how you can see in the slide right there. And that's whenever we can kind of leverage those for further kind of abuse. And to me, I think this is a really neat attack, because I've never really heard anyone talk about it besides CloudGoat. And I think that it should be something definitely people are looking for whenever they're doing any type of AWS pen testing. And so once you have those tokens, as I was mentioning before, if you're able to take that identity ID, so if you have the identity pool ID, you can typically send a request, and there's a certain type of request you have to send, and that will provide you the identity ID associated with that identity pool ID. And then you can send it with your token to essentially obtain authenticated access key and the secret key associated with that AWS authenticated user into that organization. So that's kind of an example I have right here. And so that's using that authenticated user we just created with the identity ID associated with that identity pool ID. And then we're getting those credentials to essentially have that to kind of move into their environment. And if you didn't want to go the authenticated route, I think it's the weirdest misconfiguration. I don't think it should be a configuration, but this is something that is occurring a lot in the Cognito app as well. But essentially, if you just have that identity pool ID, and and then you get the identity ID, you can just request unauthenticated temporary credentials. So a lot of times there actually is a real case for having these types of credentials that are unauthenticated with the Cognito user pool. But I just think it's very odd to have this type of configuration. But essentially, you can just pull down, just by having that identity ID, temporary unauthenticated credentials, as you can see here. So sometimes they'll be locked down, but if the organization doesn't have it configured properly to where whatever permissions are on that user, then someone could potentially use those credentials to kind of enumerate the environment. I haven't, in a real case environment, I have not come across this being able to be used. The credentials were completely locked down and we couldn't do anything with it. But I have seen other cases online where they were not locked down and people were able to leverage that unauthenticated users' credentials associated with AWS to kind of go into their environment and laterally move around. So to kind of mitigate this type of issue, as I was mentioning before, making sure the sign-up operation is not enabled. It's probably the first step that you take. And then for that authenticated and unauthenticated user that is associated with that user pool, making sure those permissions are locked down, especially for the unauthenticated user, because say if you have the sign-up disabled and you still have that unauthenticated user exposed, you want to make sure that user has least privilege, if anything, nothing. Whatever just what that user needs to do. So just making sure that's super locked down, and then making sure that the identity pool ID is not hard coded into any responses or any SDK files that are associated with that Cognito user pool.
Awesome. So pivoting over to Azure, we talked about AWS device code phishing earlier. So now we'll talk about Azure device code phishing. I had mentioned earlier about password guessing against M365. Nowadays, with all the additional security mechanisms, conditional access, and multi-factor authentication in place, a lot of times credentials really won't yield you any additional access. So with Azure device code phishing, basically kind of follows the same approach as AWS, but you're going to be targeting specific M365 APIs. Let's say the Graph API, which is a very powerful one that can give you enumerate a lot of information about organization's tenant. But basically, this access token versus a user's credentials, the benefit here is we will show on the next slide, but you'll basically inherit the token authentication imprint of the user that authorizes that device code. So if they are logged in to a machine with their MFA account all set up, you will inherit that token with an MFA imprint. So in some cases, you may be able to bypass MFA when enumerating different Azure APIs or MSOL APIs. So continuing on with the Azure device code, those two screenshots you can see down there in the bottom, that's exactly what I was talking about with the MFA imprint. So the token on the left was either grabbed with initiating a primary refresh token by joining Windows VM to Azure. Let's say if you had user credentials, but the one on the right is access through a user that was phished and provided their access token from a logged in machine. So with that, you will have that MFA imprint, will let you bypass MFA on a lot of M365 APIs. So there's a couple different tools you can use. We mentioned token tactics. That is one of the tools that it really allows for seamless use with PowerShell to generate, as you can see there in the top right, a token for whatever API client you're looking for. In that case, an MS Graph token. They're valid for 900 seconds. And if a user submits, authorizes that device code within that time, you'll gain access to their access token, which I believe they are valid for either 90 or 180 days. With that refresh token, you can trade out different tokens to other APIs which makes it even more beneficial for accessing other resources and enumerating them. So moving on here, we have that 900-second thing that we were talking about earlier. Basically here, this is a tool similar to the one that was used with the AWS device code fishing and setting up API gateways. I'm sorry, not 900 seconds, 600 seconds. But basically, this allows you to not be limited to that 600-second expiration time of your device code. So there's a few different ways you can set this up with token tactics, like I had mentioned earlier. It's dynamic generation of URLs. So you can basically set up a either VM or Azure web app if you'd like to kind of use that validity of M365 resources when you're conducting that phishing campaign. And you can load this HTML that will generate dynamic device codes. So while your token tactics is spun up and polling, it will only generate those device codes when that user actually accesses the specific URL that you send in your fish. So it has the ability to handle multiple users and multiple device codes. So you can correlate those with the user that you are sending your fish to. Let's talk about some mitigations for this. So we briefly talked about how this MFA is not really enough to block this kind of attack. Because the reason being is users logging in from illicit locations. But the best practices against mitigating this is strict conditional access. So that would either be location and device state policies enforced. So let's say you do get access to a token with an MFA imprint. Conditional access could still prevent you from enumerating those API resources because you're coming from a different location and the device used is not the one that's enrolled in Azure to that specific user.
All right, so diving into kind of post-exploitation to kind of wrap things up. So whenever we're doing any type of post-exploitation on any cloud pen test or red teams or whatever we're doing testing for, so we kind of want to go into three different kinds of things, which would be the privilege escalation, lateral movement, or trying to exfiltrate data that could be sensitive to that client. So we're going to kind of discuss in regards to each provider some of the things that we do in the post-exploitation phase. So from an AWS perspective, some of the things that you kind of want to try to do to kind of laterally move around the environment and kind of gain additional privileges is, I mean, if you can find or create a policy that you can give yourself more privileges to, that would be kind of one method. Or if you're finding an instance profile associated with the EC2 and then attaching it to an existing EC2 role, or creating a new pair that is using it on the EC2 instance with a service profile that has those additional provisions. Or like I was kind of mentioning before, the enumerating the assume role, you can kind of do this again too later on in the lateral movement phase as well, kind of taking that and see if you can find potentially any higher level users that you can, or any policies that are misconfigured that you can assume that role for, or if you can add a user to a group, depending on what type of permissions you have with the user that you do have in that environment. These are just a few of the ways that you can kind of laterally move around the AWS environment and kind of gain additional quiz. So there's obviously more, but these are kind of just the ones we kind of wanted to highlight during this presentation. And then next we'll go into Azure.
So moving into Azure lateral movement. So we'll start with talking about hybrid workers. So hybrid workers are typically Azure VMs. They can be used along with automation runbooks in Azure. Typically, if additional resources or CPU computing capabilities are needed, that's where automation runbooks and hybrid workers can come in to play. With some misconfigurations such as exportable certificates, anyone with local admin access on these hybrid workers can potentially authenticate and export those certificates, which could potentially allow them to assume access to other roles and rights in the Azure environment. This could be because those hybrid workers may be set up with additional roles, or they may have a need to have access to other resources. So from the user that you have access to, you could potentially laterally move and privilege escalate into using these other resources. Moving on to escalation rights via service principals. So just to briefly go over, there's several different administrative roles in Azure. Some important ones we're going to be talking about here, obviously, are the global administrator, as well as the privilege authentication administrator. These two accounts have the ability to reset passwords on each other. So essentially, they are of the same significance when it comes to the hierarchy of administrators in Azure. So the reason I mentioned those two is, for an example, let's say an incorrectly configured Azure app. A user is given access to as an administrator of that Azure application. That gives the ability of that user to add secrets to that application service principal. And if that application service principal has the roles or rights of that privileged authentication admin, that user that was granted access to that application now has those privileges of a global administrator. There's a lot of different contributor roles within Azure, and it's important when creating applications or granting users access to these different roles that the roles that are associated with that application or service principal do not allow that user to escalate privileges and laterally move throughout the environment. And then lastly, you can also laterally move through that Azure CLI Cloud Shell. This is kind of taking into account the AED internals that we were talking about earlier, or a PowerShell module of your choice, where you can enumerate runbooks, service principals that you may have access to, or Azure Key Vaults, SQL databases, things like that, depending on the user that you have access to.
So that kind of wraps up our presentation. And I'm not sure if we mentioned this earlier or not, but I just want to make sure everybody knows that everything we kind of went through in this presentation is kind of the things that we saw as important items that we could include. This that definitely does not go through a comprehensive of all the different types of phases associated with the cloud pen testing, but we tried to make it to where what we saw most important whenever we're looking at AWS and Azure environments that we can leverage during a pen test or a red team or whatever type of test that we are doing, but making sure that there's so many other ways. These environments are so large, and there's just so many different things. And as new vulnerabilities get released associated with cloud environments, it's just going to continue to expand. So just be along for the ride, because it's not stopping. Everybody's going to be going to the cloud, and everybody's going to be expected to be able to perform cloud pen tests, and it'll just be considered pen tests in the future because everything will soon be in the cloud. And Aaron, if there's anything else you want to add to?
Nope, I think you pretty much covered it.
Sweet. And if you guys have any questions, we will be in the Discord after this presentation to answer anything. And make sure you're kind of following the Source Zero on Twitter as well. So that's Optiv Source Zero, and we'll have all of the updates on there. And thank you for coming to the presentation today.